Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's a problem for today for exam P on probability. The time until failure, T, of a product is modeled by a uniform distribution on 0 to 10. An extended warranty pays a benefit of 100 if failure occurs between time t equal to 1.5 and t equal to 8. The present value W of this benefit is 0 for t between 0 and 1.5. 100 times e to the minus 0.04 t for t between 1.5 and 8, and 0 for t between 8 and 10. Calculate the probability that W is less than 79. And here's the solution. So first we note that probability that W is 0 is the probability that t is less than 1.5 or t is greater than or equal to 8, because in that case the warranty doesn't pay anything. And that's the probability that t is less than 1.5 plus probability that t is less than or equal to 8, because these are two mutually exclusive events. Given that the probability distribution is uniform between 0 and 10, the probability that t is less than 1.5 is 1.5 divided by 10. The length of the interval where we have uniform distribution is 10, and the interval where t less than 1.5 happens is of length 1.5. That's why this probability is 1.5 over 10, plus the length of the interval where t greater than or equal to 8 happens is from 8 to 10, so the length of it is 2. The probability that t is less than or equal to 8 is 2 over 10. The total of these two is 0.35. Furthermore, the probability that W is between 0 and 79, not including 0, that's a probability that 100 times e to the minus 0.04 t is less than 79, because that's the form of W, what W is equal to between the interval of 1.5 and 8, and this event is in intersection with t between 1.5 and 8, because that's where it happens that we can write W in this form as 100 times e to the minus 0.04 t. Okay, but this inequality 100 times e to the minus 0.04 t less than 79 is equivalent to e to the minus 0.04 t being less than 0.79, and then we can apply the natural logarithm of both sides and get e to the minus 0.04 t being less than the natural logarithm of 0.79, and then divide both sides by negative 0.04, getting this inequality to be equivalent to the probability to the inequality that t is greater than ln of 0.79 over negative 0.04. Note that both of these numbers, both the natural logarithm of 0.79 and negative 0.04, are negative, and we switch the direction of the inequality because we divided both sides by a negative number. So we get the probability that t is more than ln of 0.79 over negative 0.04, intersection with 1.5 less than or equal to t less than 8. But because this ratio ln of 0.79 minus divided by negative 0.04, or minus 0.04, because this number is actually greater than 1.5, this probability of the intersection of two events is simply the probability that t is between ln of 0.79 divided by negative 0.04 and 8. And that probability, because of uniform distribution of t is simply equal to the length of the interval where this condition is satisfied divided by the length of the entire interval where t is uniform. So that's 8 minus ln of 0.79 divided by negative 0.04, and the whole expression divided by 10. And that's approximately 0.21069,417. And then the probability we're looking for is the probability that w is less than 79. That's the probability of w being 0 plus probability that w is more than 0 but less than 79. So it's 0.35 plus 0.21069,417. And that's 0.56069417, and that's answer D. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.